In earlier videos, I had shown you how to use Ansible to configure VLANs on a couple of Nexus switches. Now let's go ahead and look at some more aspects of this process. And in particular, I want to look at the issue of, well, we've now made configuration changes and we need to save the configs of the devices. So we need to save the configs from the running config into the startup configuration. So let's go ahead and look at that, and as part of that discussion I want to add into there this issue of using handlers inside Ansible to accomplish this. So first of all, let's go ahead and start by looking at this inxos VLAN file. So we'll go into this file. We'll go ahead and set this up here. Everything else is commented out. So all we're doing here is we're going to configure two VLANs, and we're going to use NX-API in order to accomplish that. So let's go ahead and run that and see what happens. Okay, so it's configuring the black VLAN, or more exactly, the black VLAN is already configured. The orange VLAN is already configured. The pink VLAN is already configured. It had to configure the pink VLAN on NXOS1, and it completed its VLAN configuration. Now at this point, the configuration change is in the running config, but it's not in the startup config. So let's look at how we could just go ahead and add it into the startup config, i.e. how we could accomplish the copy run start operation. So if we go into NXOS VLAN, and I'm going to go ahead and copy a few lines here. And we'll make this be copy run start. Now notice here that I'm going to use SSH to accomplish this. I'm using the NXOS command module, and I'm providing a single command, which is copy run start. Let's go ahead and add in a tag, and just so we can see, does this module execute properly? We'll just call this Write Mem. We'll go ahead and do our playbook execution, and we'll see if it operates properly. And I have an indentation issue. You can see my indentation is off by 1 if I compare the indentation of this to the indentation of that. So I'll indent it one more, indent here, indent here, indent here, re-execute the playbook. So now it should be executing the copy run start. And we wait for that to complete. Now let's go ahead and add on to this a little bit more verbose so that we can see what happens when we run this playbook. So still just running the copy run start on those two Nexus switches. Okay, so now we scroll up a little bit, and now the Nexus does a funny thing where it repaints the line to give you a progress bar. So you can see that happening here on the one switch. It's progressing, and then it says copy complete. But now we can tell that it did do this copy run start operation. Now, one thing that's not great here is that it marks this as a non-change operation. That it just shows you this as being okay, i.e. it's telling you that it didn't change the state of the device, even though it did a copy run start. So that's because Ansible thinks that the NXOS command module, it thinks the commands you are executing are show commands. So what I like to do when I'm doing a copy run start with NXOS command or iOS underscore command or EOS underscore command, etc., is I always like to flag it as being a changed when true. So this is going to make it be so that anytime I execute this, it's always going to flag this as being changed. So now let's go ahead and execute that and see if it marks it as now being changed. And while this is executing, I want to start talking to you about another issue with our playbook. Now, if you think about it, our playbook could have a series of tasks. Say in task 1, we configure a VLAN. In task 2, we configure some IP interfaces. In task 3, say we configure some BGP peering. Now, you don't know if any or all of those tasks caused a change to happen. So here we have an NXOS VLAN task where a change could have happened. Like I said, we could then, in the next step, we could have had an IP interface command where a change could happen. We could then have a BGP configuration operation where a change could happen. And we could do a write mem after any of those. We could do a write mem after all of those. But in both cases in that situation, you would always be doing a write mem, regardless of whether, in this particular example, regardless of whether the NXOS VLAN action actually causes any changes, we're always going to save the running config to the startup config. And that has the undesired effect of that we're sort of always making a change, in a sense, to our device. Regardless of whether we didn't change anything, we're making a new copy of the startup config. So Ansible has this nice feature called handlers that will get us out of doing that. And what I can do with a handler is I can specify a notify operation. And with the notify, I make this identifier string exactly match the name of the handler. And this handler is going to be called write mem. And then I'm going to make a new section called the handlers section. So in the handlers section, I specify all my handlers, and here I just have one, and it has a name of write mem. Now what this is going to do is, it's going to go through this task, and if this task results in a change, then this handler is going to be fired off at the end of this task. And then it'll cause this to execute. If this doesn't have any changes, then this handler will never fire off. Now similarly, let's say we actually had 3 tasks, and I'm going to simplify them somewhat. But say we had a task that did something like, IP interface, and something that did like BGP. And obviously these are simplified. I've dropped their arguments. I might have messed up the module name. But we could have these 3 configuration operations, and each of those call this handler. Now what it'll do is it'll march through these tasks and it'll say, did I make any config changes here? Yes or no? If it does, it sets this flag, but it doesn't actually call the handler until all the tasks in this section are done. So we could have made a configuration change on the VLAN here. It'll set this notify flag for write mem. It'll then go down to the second configuration action and see, did I make any changes? Yes or no. It'll set the flag if it needs to. Goes and makes the third configuration change. With BGP, sets the flag if it needs to. Then at the very end, it checks, did I set any handler flags? Yes or no? And here, let's say we set it at the very first one, so it did set the write mem handler flag. It'll then go and execute that handler, or if there's multiple handlers, those handlers, in which case the write mem will be saved. So we have this way of knowing, do we need to execute this at all for a given set of tasks? So now let's go ahead, since these are not fully completed config sections or task sections, let's go ahead and simplify it back to here. We'll go ahead and execute this playbook. We'll go ahead and see what happens. So here we're doing our Nexus VLAN configs. Now notice the black VLAN was already previously configured. No actions need to happen there. The orange VLAN was already previously configured. No actions need to happen there. Same thing with the pink and the brown. So notice this task for configuring the VLANs. There were no changes. Consequently, the handler never fired off. The write mem operation never occurred. Now let's go ahead and blow away VLAN 552. We'll go ahead and remove that from the two Nexus switches. Okay, so VLAN 552 has been removed. Now we'll re-execute our playbook. Now we see the black VLAN already exists. Now we see VLAN 551, the orange VLAN already exists. We get up here to VLAN 552, and there should be a change that happens. So there we see it had to re-add VLAN 552, the pink VLAN. Now notice the handler for write mem is now operating because now a change has happened, so it has to run the write mem handler, and it should do it on both of the two Nexus switches. And then there we can see the write mem occurred. Another situation where you could think about using handlers would be this common situation, at least for Linux administration, where you're doing something like rebuilding an Apache config file or an SSH config file, and then you want to restart the service when the configuration is all done. So you go through a series of operations. If any of them change the Apache config file, then you know at the end you're going to have to restart the Apache service. You would notify the, that corresponding handler, and at the very end of those set of tasks, Apache would be restarted.